10 feet कमी हमारा
निकाल के रखते हैं. He's also having the farm. So we want to buy first. I told you. Just to show one. I have Shivani's number. With me. लेकिन अगर सर सर्टिफिकेशन नहीं है तो अगर कुछ एग्रीकल्चर एक्सीडेंट्स डंडे के साथ यानी अगर हम तीन चार तो कैसे भी नए में नहीं ठीक है
नए में तीन है पुराने हैं
अभी जस्ट एक महीना हाँ
साथ में रोटावेटर सब एक्सेस
Good afternoon. I think it's time to start our afternoon session. So, please move into the seats here. वहाँ से इधर आ जाइए. टेबल संभालने पर यहाँ भी आइए कहीं भी आइए. Sit on these tables. इसमें फोन नहीं रखे ना सोने. मुंडी भी जोड़ क्या मनोहर संबंधम प्यारा प्यारा संबंध. Very good. So you put us together. Okay, that's great. So he is going to speak about mechanization of cotton picking. This is really a very serious issue because of labor shortage. So, can you introduce yourself, Dr. Sunil Vandana?
Yes, I am.
So please now give all the attention to the speaker.
Yeah. Okay, I'm assuming everybody is interested in listening, and thanks for coming down here, and thanks for the AAAE for inviting me and presenting this. My name is Ch.Sambhajinagar. I'm a farmer. I've been farming for the past 15 years. I've been doing cotton as one of the crop. I am in have a small 5-hectare farm in Tamil Nadu, and we do 2 crops. One is paddy and another is cotton. And all the problem I am trying to solve is and because of the cotton. The problem I had triggered me to start this company, Green Robo Missionary. We call it in short RoboMac. I'm the founder and an entrepreneur. So my speech or talk is more from a farmer's perspective and as a tech entrepreneur point of view. Foremost farm robotic event, and I just want to share a few things before I get into cotton. Specifically, this is next slide. Essentially into harvesting. We'll talk about those two companies, Portugal, later also. Next. So this is just a picture of everything you will see. I have seen all this demonstration on the field, and they are pretty good. We should not be hesitating to talk about farm robotics anymore. It's not a lab situation, but it is really a practical solution. The only problem I am seeing now is how commercially viable they are. So if you see all of them, they are in very specific crops. Most of them are either in California. It's strawberry is one of the very big commercial crop, and many of them will be in the strawberry. The Tortuga is also a strawberry picking mission, and they also do what you call they do grapes and few other things. Pretty precision things. And the technology used, the machinery itself is pretty good. All farm machines are pretty robust and fully autonomous, and most of them are using precision mechanical weeding or using carbon lasers for weeding out, and carbon lasers are used in specific crops. And the Alphara is actually a cotton picking machine, which is very similar to what we are doing there. So next, please. Okay, like coming to cotton, why cotton, right? We in India is the largest producer of cotton in the world, around 24%. We have around 12 million hectares, which is about 1/3 of the world cotton land in the cotton, right? But still, if you look at it, our productivity is very low, right? World average around 1,000 kgs per hectare linked, and we are around 532. So what is the reason? One of the main reason is that we have zero mechanization in cotton in India, except for the land preparation. I listed out all these tasks which a typical farm operation is done. We don't do anything like pruning, topping, and thinning in cotton. Definitely not. If I do it, a lot of data shows that it will get 20-30% more yield, and we don't take care of timely intervention of any task in cotton. Like first 60 days of cotton is the most important day. Cotton is a 150-day crop, but if I don't take care of the first 60 days, I think you will not get any yield. Like topping will give you around 20% yield more, which I do in my farming, and these are all very labor intensive. So fundamentally, we don't have labor. The harvesting is today cotton is hand picked. Harvesting is the most labor and we require high precision. It's a high pressure, right? And next slide, please. So all of cotton is done by I have 5 hectares. I can't do more than 1-2 hectares at all, right? Because I will not get the labor there, and so you can see a lot of productive land actually lying fallow in at least in South India now. Which is cotton, by the way, is one of the very good commercial crop from a farmer compared to paddy. Paddy gives you 30,000 rupees. Cotton can give you anything like 1 to 1.5 lakhs, which is opportunity lost for farmer, right? And today, cost of harvesting is very high. It's almost 50% of the crop production itself. We pay around 15 rupees per kg of picking. So essentially, the problem is big time labor. Labor is available, but we don't get enough during the time we require. Next. So, having said that, is there no machine in the world? Yes, there is. There is pretty good mechanical harvesters. What is the problem? There are few problems. One of the fundamental problem it is all it's a single time harvesting. Most of the machines they claim they can do multiple harvesting, but it is not so. We call it synchronous bloom. We create a breed which can bloom at the same time by adding PGR, plant growth regulators, and a defoliant. Crop to do a synchronous thing, especially for small farmers. We actually had to have 4 times the seed rate, and we had an extra PGR and a defoliant, which is probably not good for an Indian farming condition. But of course, it is happening in the West. There's no issues at all, right? In the thing that the mechanical harvesters, you will have a 10 to 15% loss. There are some percentage of it goes down in the ground, right? There is one company doing specifically solving that problem. Then there's also the cotton harvested is unoptimal. The yield will be unoptimal, like typically a synchronous bloom cotton will give you 40 bolls. 40 boll is a bloom of bloomed cotton. And what we have the regular variety hybrid gives you 100-120 bolls, right? The quality also will be bad because they have to harvest at the same time. They allow the crop to be in the for longer time, right? So you lose the color, and also the mechanical harvesters damage the fiber, and so you lose the fiber length. And of course, soil compaction is a problem with the large crops. Next. Right. So worldwide, what's happening? Agara, I talked about it. They are actually picking cotton from the ground. It's a company in Turkey. Turkey uses John Deere and even our Shaktiman. Shaktiman has a cotton harvester, which is not used in India. They pick cotton from the ground. They use similar technology from what we do. They claim that 20% of the cotton is actually falls on the ground. Cotton Corporation in US, the other 2 problems, compacting, bad cotton yield, and all those things are addressed by company, by an organization called Cotton Corporation. They have a huge funding for what you call as picking cotton. Precision picking, and similar to what we in India are doing. Agara is a commercial company. In India, there are many efforts going on. I am Green Robo Missionary. We're doing a cotton. I'll talk about it later. There are other universities are actually doing something now. You know, CMRI in Ludhiana has been trying to do this for past 10 years. I know that the vision-based picking, but they've been too early on that, and then dropped it, I guess now. So, but there are others, as we speak, there are other people who are actually trying to solve the same problem the way we are doing. Next. So, this is what we as a company are doing. What is our unique selling proposition? Basically, we pick cotton multiple times. That's basically called multi-bloom. So, you don't need to change any agronomy. Right, you don't have to do what's called high density planting or whatever. The mission itself is a 3-wheel driven, 3-wheel steered. So it's a very compact mission. You don't need any headland. Headland is a space required to move the vehicle, turn around. We don't need any headland here. That's very important in Indian condition. I'm building a mission purely from an Indian perspective, not for anybody else, but it can work in any place. Right? The picking is completely autonomous. It's just that's the way human picks it. You can detect and locate a cotton, and then we have a cotton. I'll talk about it later in more detail. The guidance of the vehicle is semi-autonomous because we have an electrical mission. If you have some smart guidance, we can run it on a row. A cotton is a row type crop, so we don't want a human to intervene while it is picking. So we're trying to make it fully semi-autonomous. So I start the mission here, it should end at the end of the row. And then the person can come down and turn it around. We can completely automate it, but I don't see necessity for that. It is completely operated by women. We don't need any power. It's electrically operated. You test it. It has the brakes and it has enough torque to move up and down the road and bunds, moving from one field to another. From a technology perspective, it uses whatever is the latest in the world, which everybody else is doing. That is basically, we use a 3D vision camera for detecting and locating cotton. We have an AI for detecting things, and then we have built our own custom robotic arm. What you see, the 3 arms there. Right? And the target for us is to pick 50 kgs per arm per day. And our commercial mission will have 6 of this, which is essentially gives around 250 kgs per day. And it will essentially does a job of 5 people with one. It's a walk behind mission. There is no thing. We don't run. It's a walk behind mission. It's a very slow moving mission. Right. This is a overall architecture. This you will see in any farm robotic. I think this will be the technology we're using. Someone will have a camera to detect. Typically a stereo camera. There are other reasons why stereo camera is used. And then there is an actuator. Actuator is very, very specific to cotton. The one on the arm is actually different. I will show a little. The next slide I will show a different thing. And then we have built a custom arm. I needn't have built a custom arm if not for transporting. And then there is a standard controller which we use. There are 2 software components. One is the detection, which is basically an AI tool. We run YOLO V7, and then a positioning engine for positioning the arm. And it's just a 3-degree position. We can, whatever the camera can see, I can pick. If there is a lot of foliage, we will not be able to see it. So there are challenges there. Next slide, please. So I have been on this for quite some time. So I had 5 different versions of these missions. The first mission was the prototype. What I call now is beyond the prototype. We have a commercial. The mission you saw is a 3-wheel. Here you can see multiple versions, and there is one mission to go between the rows, and all of them are 4-wheel here, except for this. But we have been iterating through it to get to a perfection where we really require. You will identify there is a over-the-row mission, so a tractor cannot be used here, right? A typical cotton farm crop is around 5 to and above, so you need to go row the crop, right? Next slide. And this is I have gone through some 9 versions of the robotic arm. Currently, more or less the one you see there is what we're using. It's a 3-degree arm. But we have a 7-degree arm, and assuming that we can go beyond the plant and anything, but we kind of made it simplified and made the 3-degree arm. And the actuator is probably the biggest challenge we had. We have 6 rollers and 3 rollers and many more. I'm just showing a few of them here, and that's a single roller. Currently, we are with a single roller 6 plates mechanism and at a particular RPM. And we also use vacuum. Vacuum is not for picking, it is to help us in position accuracy. If I have a tolerance problem in the pushing the arm, vacuum helps in pulling the cotton in. As long as the cotton hits the blade, we'll be India, you have to build the actuator which can't meet all pick any varieties of cotton here. Next slide. So what are the real challenges, right? The real challenge is actually in the reliability. I think technology is mature. You should not be worried about technology anymore. Enough technology is there. It's mostly about the reliability. How much can you run? I pick a cotton every 2 seconds. One cotton is picked. So and in one day of 10 hours, we'll be picking some 10,000 cotton by 1 hour. and it's just a 4 gram, 3 to 4 gram is one cotton's weight, right? So reliability is has to be very high, and we are not there yet, right? And we have to look at all variability of crop. One is irrigated. Around 40 to 50% of our Indian crop is irrigated, and remaining 60% is rain-fed, right? Rain-fed has a different kind of foliage. What we see in Akola is one of the well-irrigated crop. We have very good yield here. You have a lot of foliage, so you will have a big challenge in moving the vehicle inside, right? So row spacing, typically it is 3 feet row in most of India, but high density planting, which is what the universities are promoting, including Parbhani, is a 2 feet row. So what do? I have to change the vehicle, right? And then there's a high density HDB is typically in Gujarat, and in fact Parbhani has asked us to build a 7 feet row mission for some reason. I don't know the real reason, but Gujarat is a 4 feet row. They do an intercrop of legume in intercropping, right? So,
Green gram.
green gram, yeah. And then should I do a single only picking, or should I do something beyond that, right? If you look at the economics and social aspect of it, the person who actually sees the cotton are the people who come and do the harvesting, right? If I do only the harvesting, I don't think people will come for me for seeding. That's a different challenge. From an economic point of view, we probably, in our mission, we are planning to do both the seeding and harvesting, and also the spraying. We don't have to do that. There are enough seeders available. As long as we can go straight, we should have the seeder, and then it will be a fully end-to-end mission. But then it's a question of cost and economics, right? I believe that building an end-to-end mission is what we really require. And we can do other things like topping. Topping gives you another 20% yield, right? And the other thing is ease of operation. We are an electric. There are farmers who will say, give me a diesel, right? It's much better. And that's one thing, but we have built an electric machine, and the cost is coming down. Today it's 80,000 rupees for the 2 kilowatt 48 volt battery. I think will come down very drastically in the next few years. And maintainability is another challenge. Our end effector is typically costs around 1,000 rupees one season. I'll throw it and replace it, but not so the case with the arm. So that's all I have. Thank you for your time.
Thank you very much. I have a very simple question. When you say walk behind, so if the few places left out, the operator can pick up those?
I don't think, yeah, that is exactly what we plan to. We don't want to do 100%. It's going to be taking a long time. So a person is always there behind. The person walking behind should pick up the remaining what we cannot pick. I think we probably will pick 90%. 10%.
Also, being a low machine, we should be able to set a spraying and other thing. We should be able to do weeding also.
Yes.
Because that's another major operation.
See, we plan to collaborate with other people. Weeding, we want to do precision weeding. Today, in my farm, we do chemical weeding. So it's very simple. But you want to do a spot
Are you working with any university?
Yeah.
We are working with them. Now we want technical.
Actually, my mission is there with Parbhani. I'm hoping that some people work
Because
on
the
it.
universities have a public money.
Yes.
So,
Yeah, I know.
and their objective is to help farmers. So I
The
think
challenge is actually not technology at all. It is trying to make it as robust as an automobile. We are great in automobile industry. Robotics not anywhere close to that.
okay. So anybody else have a question?
So what is the price of this 3-arm robotic arm?
See, I am targeting to bring the mission to 5 lakhs for a 6 arm. Okay, that is what practically will be useful.
And is there any problem of trash content?
Yeah, I claim there's no trash. I claim there's no trash. It is see, it's basically how good is your positioning so that you can pick, right? I claim there's no trash, but yes, that will be a little bit.
So you have to take claim is a claim.
Yeah, if I do a marketing, I say no, right? But practically, yes, there will be some.
Thank you.
Actually, Dr. PDKV Akola, CSCR Nagpur, and Dr. Shigao Engineering College
we can work it, and make it usable and path. Thank you.
I'm
And my
working
best
with
wishes to
Dr.
you.
Shinde.
Yeah, my best wishes to you.
Thanks.
Okay.
One
Thank you very
important
much.
thing I want to add to rest of the student is, see, the farm robotics is in the next 5 years you will see more humanoid robots coming into the farm. Right, there are a lot of companies building humanoid robots. Training them is very easy. We have what is called reinforcement learning and everything, and I believe the next 5 years you will see humanoid robots than what we are doing. So people who are working on should be looking at the humanoids and how to train them. All the technology we are doing here will be the same thing in the humanoid robots. Humanoid robots today is around $20,000. You will see the Teslas and Figure and everybody building them. They'll be commercial in the next year or so. But they can be very well trained to do any kind of action, and whatever humans can do, they should be able to do it much better and much more reliable. Thanks.
Thank you very much. Come. Okay. Next one, Dr. Surendra Kalbande.
Yes, sir.
Oh, you're already there. Okay, utilization of solar energy for integrated pest management. Can you introduce yourself?
Yes, sir. So, good afternoon, respected Dr. Gajendra Singh, sir.
No.
Honorable Vice Chancellor, sir. So, myself, Dr. S.R. Parbhani. I am working as a head of the department of renewable energy engineering and also holding the charge of being faculty of agriculture engineering at Dr. PDKV Akola. So, utilization of solar energy for integrated pest management in agriculture. Next. So, this insect pest and diseases, and this weed, we know that it causes the considerable damages to the crop, and this insect pest causes 25% loss in rice, 5 to 10% in wheat, 30% in pulses, and 35% in oilseed, 20% in sugarcane, and 50% in cotton. And these losses can be eliminated altogether, but we can reduce these losses. So there are various types of traps and different techniques. There are biological controls, chemical measures we can use, and mechanical controls. So this light trap, it comes under mechanical control. So electrically operated light traps are available in the market, but in some cases where the electricity is not available, in such villages, in such areas, we can use this solar operated light trap. Also, in addition to this solar insect light trap, we can use in combination with this insect trap, sticky trap, then pheromone trap, and these are the best solution. And we can save around 30 to 40% of the these chemicals which are used during the this farming system. Next. So these are the integrated pest management IPM technique. In this integrated pest management, it is a broad-based approach that
So the topic of my presentation is design and development of bund cutter for paddy cultivation. Now, in the cultivation of paddy, the bund of the field it plays important role, and as the seepage loss is more from these bunds, so this bund should be cut properly and it should be compacted so that the seepage loss from this bund is reduced. So traditionally, the bunds are cut with the traditional methods. Next, please. Next, please. So previous one. These bunds are actually in traditional methods. They are cut manually, and average skilled person can trim and plaster 90 to 120 meter of bund per day. So there is a need to mechanize this bund making process to strengthen the existing bund ridge and without damaging the height of the ridge. Next one. So the objectives of this study were to design the bund cutter for paddy cultivation, to develop the bund cutter as per the design, and to evaluate the performance of newly fabricated bund cutter. So the picture shows the traditional method of bund cutting of paddy field. Next, please. So this is the methodology how the bund cutter equipment is designed. So power requirement was calculated, and selection of power source was done on the basis of this power requirement. So it was designed for a medium range tractor, that is 35 to 45 HP tractor. So most of the farmers, they are using small tractors nowadays, and that's why this bund cutter was designed for this low HP tractor, that is 35 to 45 HP range tractors. So again, these are the calculations for drawbar pole, width of the implement, and unit draft. And next, please. So these are the pictures for the design bund cutter, hitching flat, isometric view of the main frame, and side views of the frame and the cutting disc. Next, please. So this is the isometric view of bund cutting equipment. It has two discs and at two edge corners of the main frame, and there are 19 number of pegs in between these two discs. Next, please. So these are the specifications of this bund cutter or bund cutting equipment. Power source is 35 HP tractor, length is 280 centimeter, width 50 centimeter, and height 71 centimeter. And the cutting disc has the diameter of 35 centimeters with the thickness of 4 millimeter. Total weight of the implement is 115 kg. Next, please. So this is the performance evaluation of bund cutter in the field, in the puddled field, and the below picture shows the previous field view before operation and field view after operation with the bund cutter. Next, please. So this is the performance of this bund cutter, showing the depth of cutting and operating width of the bunds. At the performance was carried out with the three range of speed of operations, that is 1.5 km per hour, 2.5 km per hour, and 3.5 km per hour. And the fuel consumption, it was lesser in case of 3.5 km per hour speed, and it was 2.71 liters per hour. Next, please. So this figure shows the field capacity, that is theoretical and effective field capacity at three different speeds of 1.5, 2.5, and 3.5 km per hour. Next figure is of effect of travel speed on field efficiency. So field efficiency was higher again in case of third speed, that is 3.5 km per hour, which was 84%, and the lowest was in 1.5 km per hour, 75.41%. Next, please. Yes, sir. So this is the field performance of this bund cutter at different speeds, with the bund cutting efficiency of 84% in 3.5 km per hour, and cost of operation was 551 rupees per hectare, again in the higher speed, that is 3.5 km per hour. Next, please. So these are the conclusions. Average operating width was 14.27 centimeter and depth 29.48 centimeter of operation was maximum at a higher speed of operation 3.5 km per hour. Wheel slippage was 28.07, 22.68 and 17.37%. Again, it was lower in case of higher speed. Fuel consumption was again noted lower in case of 3.5 km per hour. And the cost of operation was again 551 rupees at the higher speed of 3.5 km per hour. Next, please. Next one. Okay, thank you.
Thank you. Can I request? No,
He was a member. Excellent member. Yeah, industry man. We industry people cannot share their kids.
I was the question.
The industry people.
Okay, sir, I will answer first and then I will listen this.
Thank you.
Industry person was gay.
Thank you very much. But
Yes, sir.
I think I have a very simple observation on many data tables. Please, when you calculate percentage of something and you are giving figure in rupees, don't give Paisa figure of 73 and 79 and all that. Round it off to, because rupee itself is so small.
Yes.
Because you have to look at what is the importance of that, what is significance of that. जब एक रुपए में कुछ नहीं आता तो एक पैसे में क्या आएगा, है ना?
So computer point with
No, but you can always round off.
Yes.
This is your objective. Similarly, many efficiencies people calculate up to second place. And every efficiency, every calculation, every reading gives you different efficiency. But then you still give, so please put it in a round of figure, which is, now I saw the, somebody was using the waste loss, okay, like Bangladesh. It's easy to talk about him because he's not here, okay. Dr. Manjurullah, he gave the loss in the drying 2.47% to 4 point something, no, 3 point something. 2 decimal places loss, okay. Now, every sample he will collect, it will be a different figure. Okay? So he simply said 2 to 4%. Rather than running 2.07 to 4.8, so that's what I'm just suggesting to, especially the students, okay? Don't go that what calculator has given you or your computer has given you.
Such an Excel sheet नहीं हुई.
No, actually, I want to tell. This I was taught while plowing. We had an AIT, students are asked to plow with a tractor. And if Filipino measuring how much it is, they will write 15.35 centimeters. Another one 20.43. So I mean, he doesn't you didn't measure nearby there. It's instead of 15.43, it is 12.23. So this he is telling all the students. I am one of the first students listening to this. Don't worry about you students and everybody. We must be practical. What he says is actual value.
The figure should make a general sense, common sense. Just use that what is the significance of that value you are using. Okay. Yeah. Okay, now I think that we have one more. Yeah. Position. Very good. So, sir, introduce yourself. Go ahead.
Good afternoon to all. My name is Kodeshwar Rao. I'm from Andhra Pradesh and Chennai, both the places traveling, and Chennai address. And I'm here as a attendee only, but my TNKU team is encouraged me to present my small invention or one of my equipment seminar. Especially Dr. Alaswan is helping me preparing the small slides to present this small report for the small farmers. Before proceeding further, I would like to introduce my firm, what we are doing, what made us to go for this equipment. So we are having a farm of 50 acres in our village. We are having a farm in Andhra Pradesh, 50 acres of land. From 2014, we are doing a natural farming. As Indramani sir said, we are not using any chemicals since past 9 years. It is a purely organic and natural farming farm. We not used a kg of fertilizer, chemical fertilizer, or any pesticides, all are cow-based cultivation in between. This farm is a rain-fed area, rain shadow area, drought-prone area. In spite of that, we are able to achieve this because of the natural farming. It's helping us a lot. Also, our input cost was very less. Input cost was very less, and we are having a problem of labor problem. That was the high cost. Our input cost was the labor cost high. Sometimes they are not coming also. Because of that, we are losing our crop harvesting time, and some damages are happened, which made us to think of an alternative. If we are looking for machines in the market, all are manned engines. So my wife is the one who is doing the natural farming, being a lady. She said she need to continue this farming. I said we can abandon, we can leave it, we can go for some other business and all. She said she wanted to continue the farming. So we decided, using my background as a mechanical engineering, I started working on it, what machines we can do. So we started taking up a small machine, which is a multi-purpose agri-robot, which can do a small, generally it is not for replacing any tractor. It is a small mini tractor, which is meant for only organic farming, where we don't go too much depth land. Normally, we do only 2 inches of depth for plowing. This machine is for 4 purposes of using: small plowing and seeding, spraying, and weeding purposes been used. The picture shows the side views of the robot. This is the rear wheel. That is the front photograph of that. It is running on electrical motors. Battery operated. We are also having engine mounted equipment inside for a gearbox, and it can cutting for the grasses. At the same time, it can charge the batteries using an alternator. It has got an attachment. I can attach the plow, and the rear side I can attach a seeder. I can attach sprayer units, which can be used for small vegetable farms. If you increase the capacity and the wider things, you can use it as a tubular cut principles. The small farmers are using it to put tubular bulls. They can replace that one. The next. This is last January. This place my district. This is how my character and as I speak. This is also powered by a solar. In case if you are continuously working in a field, you will charge. Field pictures I have not documented. Some I need to do as editing and all. That's the reason I have not brought. We can use it. This is morning 9 to 4 o'clock. Field, it continuously charges the batteries. You can do the weeding and spraying works. With the batteries, I can this design for only 3 hours of it. This machine is operating on a remote. The machine is their autonomous completely. Program flow modules are there. Is the one for the seeder. Autonomous will be ready another 50 days.
Down பண்றீங்களா?
Width of the machine is 2.5 feet, sir. The length is around 4 feet. Basically, I designed for my chili crops, weeding and chili. We maintain around 2.5 to 3 feet width. Each. We can attach the bundling also.
அந்த சைடு தான் ரொட்டேட் பண்ணுங்க.
This is a small presentation about this machine.
Do you have an agriculture engineering college near you?
Yeah, Bapatla is this.
There's a big faculty there. So
Now they have given an application. Angru is taken up by this thing, and they will assist me.
it's a very old college.
Yes, sir.
There must be some interest.
Yeah, now I submitted this thing, they have accepted this thing for scaling up this.
So it will be very interesting for students to.
My classmate and friend is dean of the college.
Even this Andhra also accepted.
He is very active. I have to make a comment. He is very active for 1.5 years in the group also. He was asking 1.5 years back, I want to make the robot one because his wife also very intelligent. She is managing the farm. She has given a webinar series for us also. She is very smart. And they are very, very advanced people. Rather in a small Andhra farm, they want to go.
The first ones are apart from institutions, I am the one using a precision agriculture. Sir. My farm is being leveled by laser leveler. I have used digital maps using a GS and soil analysis reports. We made reports in 2017, and I use a weather station from my farm. This is from around 100 kilometers.
That's not bad.
It's on the western side.
Maybe always go for shipping for 6 months so we can dream like him and come do a wonderful.
That's
I
our
really,
boss, sir.
I really appreciate.
Boss now is a farmer.
Excellent work. Yes.
So that helps me a lot in this automation of the shipping.
Like
on the right.
another entrepreneur to honor you. Like you get a farmer.
Both of them, yeah, that is what the change, what we are trying to make.
I hope the university fellows really accept them and recognize.
I mean,
You already.
he's doing on his own,
Yeah.
just imagine this.
This is the platform. They are given an
He's already
opportunity to
connected.
produce.
Yeah.
Alone, he's alone, and he's very, very active person. In our group also, he's such an active person. If I tell something about, anything about maybe doubtful or cotton picking, that's all. I mean, so much advanced in technology. No, cotton is actually very interesting because 5 to 6 picking they do here. And before 2 years old, they lost a lot of crop because rain suddenly, they cannot do 2 pickings more. It's not like Australia. So.
Okay. Thank you very much. Now, next, we have only, what we will do, try to finish before tea. But let's say, we still have a lot of time. Okay. So next, I have Bhagyasri Patil. Good, good. So we have beautiful people left. Okay, it's a good finish. Now,
Which one you want?
Bhagyasri. So you are going to development detector device for ethylene gas. Okay.
Respected dignitaries, very good afternoon to one and all. Myself, Dr. Bhagyasri Patil, Assistant Professor, Department of Agricultural Process Engineering, Dr. PDKV, Akola. So my topic is here the automation in quality detection of fruits and vegetables. So during storage, next please. We all know that the fruit and vegetable having very less shelf life due to the higher in moisture content, and also that the fruits and vegetable are the respiring after harvesting also. So
please, I think please we have a presentation. Okay, thank you.
So we know that the fruits and vegetable having the very short shelf life and having the perishable nature. So when we store it into the storage structure, or when we store it in the open condition, the shelf life is 7 to 8 days only. So next please. So here these all are the some situations where when there will be the glut in the market at the time of that season period, that 50% of the produce get wasted due to the improper handling, then insufficient storage structure, and during transportation for the longer duration distance. So next please. So we all know that the major factors affect the fruits and vegetables spoilage or deterioration, that is the physical factor, biological and chemical factor. When we consider the physical factors, we consider there will be the temperature and relative humidity are most predominant factor which affect the quality as well as shelf life of the fruits. Again, there will be the, when we consider the biological factor, there will be the microorganisms that affect the that shelf life. And chemical means there will be the that reaction will take place inside the fruits and vegetable itself due to the higher moisture content and that nutritive factors. So my objective is to that we have to develop the device where we have to measure the gas evolve rate, oxygen, carbon dioxide, and temperature and relative humidity of that storage condition. If we know that the ethylene gas evolve rate, then due to that ethylene gas only, we predict the shelf life also. So here, with this aim, the objective is to develop the setup and program to measure the gas evolve in fruits and vegetables during storage and to test the performance of the detector. Next, please. So here, some that storage of fruits and vegetables are sometimes we store it in open atmospheric condition and sometimes we store it in the cold storages. Next, please. So this is the main that reaction takes place after harvesting. So if we store the fruits and vegetables, at that time their respiration process will take place. In with that respiration process, that ethylene gas will come out and carbon dioxide also come out, and oxygen will take in for the respiration process. So we have to measure all this gas composition, and on that basis we predict how long that if the level will takes place, means ethylene gas composition, suppose we have predetermined that level, if the ethylene gas will reach up to that, so we assume that there will be the deterioration will be start. So we have to sell it in the nearby market, or we have to send it to the processing unit. Next. So these all are the response parameters when we consider that when we test the ethylene gas with different fruits. So here banana evolves most ethylene gas as compared to other fruits. Next, please. So for development of device, these all components are required: Arduino model, DHT, then temperature relative humidity sensor, then ethylene gas sensor, then CO2 sensor, GSM module, relay module, adapter, LCD, and if we want to know if we want to know what is the percent of the ethylene gas evolved in our laboratory or any place where we have that, we have to require the mobile phone or that laptop connections. Next, please. So these all are the materials required tools for the setup. Next. Next. So this is a program of the spoilage detection. Next. So this is the Arduino program. We have installed this program in the Arduino model. Next. So this is a complete experimental setup, how we determine that gas evolved and how we have to test all these developed device. Next. So this is a complete setup, laboratory setup. So we tested this setup for the various fruits and vegetables. Next, please. Next, please. So we have tested it on the fenugreek. Next. On spinach. Next. On tomato. On mango. Next. Next. On banana. Next. On sapota. So we have tested for all these fruits and vegetables, and from this test we what we have concluded. Next, please. So we have concluded that leafy vegetables start spoilage when that ethylene gas reading starts 5 to 5.5 ppm, and that ripening of banana, papaya, and mango starts when the that ethylene gas is of 6 ppm, and start spoilage after it goes to 6.8 ppm when it's stored in the atmospheric condition, that is room temperature. So now our next aim to we have to fit this in the storage go down, then during the transportation, and we will collect the data. Thank you, sir.
Very good. Thank you very much. Good question. I think so clear to everybody. Thank you very much. That's well, Vishwanathan, you have been talking about not enough post harvest. I think we got enough today, na? Huh? Okay. Professor Vishwanathan, please all up.
Thank you, sir.
Yeah. Did you visit?
Yes.
You want it?
Yes, sir.
That's good. Yes, yes. Yes. As far as I am concerned, this is the last presentation by Dr. Harishchandra Abad.
Yes, sir.
Now, just a second. Is there anybody else who think his or her presentation is not made? Anybody? Because we can accommodate if anybody has been left out. Okay. Okay. So this is the Dr. Harishchandra. Please introduce yourself and go ahead. Yeah.
Good afternoon. Myself, Dr. Harish Avari, working as the head department of irrigation and drainage engineering, as well as chief scientist AICRP on water management. Next. Next. The topic of my study is that the determination of crop coefficients using lysometer for the precision irrigation scheduling. As we know that evaporation and transpiration is a main process when we are calculating the water requirement of the crop. Next, please. This evaporation and transpiration are also depend on the soil surface moisture and wind velocity, water quality, all these things, as well as the physiological condition of the crops. Next, please. The importance of crop coefficients is very much important because of in every irrigation scheduling and design of the project, as well as for the daily irrigation using the drip irrigation or sprinkler irrigation. We have to know the crop coefficients as well as the evapotranspiration of the crops. And whatever the values we are using in India is FAO generated, that is FAO 56 value we are normally using for the irrigating the crop, that crop coefficient. The substantial variation in water requirement during the growing period of the crop is there. Different crops in there. And knowledge of crop water requirement is important for the proper irrigation and proper quantity of irrigation that to be applied to the crops. Next, please. There are different methods that tank and lysimeter experiment, experimental feed plot, soil water studies, inflow and outflow method, and analysis of climatological data. Amongst these, the lysimeter experiments are very much accurate, that gives the values of the crop coefficient based on the water balance studies. Next, please. As we all know that the climate reflects on the water requirement, that are the humidity, then relative humidity, minimum, maximum, wind velocity, sunshine hour, and temperatures. As well as it is calculated based on the basis of the gross reference, and it comes to as we can call it as reference evapotranspiration. Then when we once know the reference evapotranspiration and the value of the particular crop that are growing in particular area, accordingly we can calculate the crop reference evapotranspiration or crop water requirement. Next, please. These are the different, as per the different growth stages of the crop. Normally we are considering the 4 growth stages: initial stage, crop development stage, then mid-season stage and late season stage, and that all 3 values are normally used as an average value. But week to week or day to day, that values are changes. That's why there is a difference in precision irrigation management. That's why we want a daily value, or at least for the week of that particular stage, and accordingly we can get the value by using the experimentation, that is very accurate experimentation using lysimeter studies only. Next, please. These data are normally available, or we can calculate from the various data sources which are available to nearby us, or IMD stations or automatic weather station, whichever available, or SkyMed data is also nowadays it is available, that can be used for the computation of the reference evapotranspiration. Next, please. Once we know this reference evapotranspiration and crop coefficient, we can easily get the crop water requirement, and according to the types of the irrigation system, we can considering the application efficiency of the particular system, accordingly we can apply the particular quantity of water to that crop. Next, please. For that purpose, at Parbhani Center, we have purchased 4 lysimeters for the studies, and on that 4 lysimeters we are conducting throughout the year experimentation for the 5 crops that are selected for the Parbhani station under the project, POKRA project, Nanaji Deshmukh Krishi Sanjeevani Prakalpa. Under this project, we got some grants from the World Bank, near about 78 lakh rupees, and from that we are conducting the experiment. The components of the lysimeters are the inner box and outer box. The sizes are 1.5 meter by 1.5 meter by 1 meter depth. Then weighing indicators are there also. Then collection of drain water, that is for the water balance study, we are calculating the drain water, and weighing indicators for the drain water are also installed there, so that we can get the daily drain water, or whatever the water is drained, whatever the water is stored in the root zone, and whatever water is passed through the environment due to the physiological activities of that crop. Next. Then weighing platform is there. Load cell are itself as given on that platform of the 1000 millimeter by 1000 millimeter, and on that platform also the data already there, and it's record the weight, daily weight or time to time weight, as reset in the time. We can reset that time from 1 hour to 12 hour also. Accordingly, we can get the data, and that data can be transferred through USB connectivity or the laptop. And control panel of the 400 mm by 330 mm and 260 mm is itself fixed with that lysometer with the solar panel, so that battery operated. And one more thing is there, the mobile SIM card is itself given in that data systems, and it reads all the data. One more AWS is nearby area is also located. There is a mobile chips or SIM card is given, and it is that data is translocated or the transfer from one to another, and accordingly all these things are recorded there, and that the preloaded program calculate the crop coefficients for the particular hour or particular time period what is set there. These are the installation procedure of the lysometers. These are the particular size of the which is sizable of the lysometer is first dig out, and the bricks are laid as a platform, and 2 tanks are installed here. Next. Also the moisture. This is standard. Okay, next please. These are the complete installations. Next please. These are the equation used for the water balance. Next please. These are the for the groundnut experimentation is carried out. Next please. These are the field view of the groundnut. Next please. All these data in respect of biometric observation, plant height, number of leaves, all were taken for the both the lysometers as well as the surrounding areas. Next please. This is what as per the standard meteorological weeks, from the data logger, the data is collected, and accordingly the week-wise crop coefficients are drawn in that below graph is shown. Also the crop coefficients and reference water transpiration shows that during the 14th, 15th, and 62, 19th week meteorological week, it goes to peak. That is the water requirement during the mid-season stage of that crop. Next. These are the average of these KC values are calculated for the 14th, 15th, and 16th week of that crop. Next, please. This is the again the average graph of the KC values for the groundnut. Next, please. These are the values are compared with the FAO values also here. These are the weak values, and it shows that it is comparatively higher than the values suggested by FAO. Next, please. These are the values are summarized in terms of the initial, mid-season stage, development stage, and late season stage values, and this indicates that the FAO values are lower as compared to the KC computed for the Parbhani or the semi-arid region of the Maharashtra. These are the conclusion. Crop coefficient values changes from place to place, and the estimated KC value of groundnut at Parbhani for initial stage are also recorded here, and it indicates that the lysometer KC value are considerably higher for the Parbhani area as suggested by as compared to the FAO 56 value. Similarly, we have Parbhani station has computed this KC value for the soybean, green gram, okra, and then rabi sorghum. This experimentation is in progress, and Parbhani station has also computed the normalized crop coefficient value for the 14 crops, and that all these values are recently we have given to the development agency Ch.Sampada Vibhag at Kinwat at Sahastrakund area. New dam is going to be constructed by the government of Maharashtra, and we have supplied. We are going to supply these all this evapotranspiration value for the particular command area as well as the case value of the prof command area. We are going to supply that license. Thank you very much.
Thank you. Thank you very much. Thank you. Thank you. I think you should. Yes. Well, again, is anybody something in your mind which you want to share with the people, which you think we should know? Or even if you don't know, please tell us, yeah, say whatever coming to your mind, yeah.
Sir, one of the from the farmers. So myself, Dr. S.B. Pawar, working as a associate research and extension agronomist for Aurangabad and journalist under VNMKV Parbhani. And so I am working with the farmers, and if you see the area under sorghum is decreasing day by day, and major problem is the labor, harvesting of the sorghum and permanent. There is a need to have harvesters for sorghum and rice.
Excuse me, sir. Can I comment?
Yeah.
Yes, sir. During my PhD work, I have developed a rotary cutting type sorghum harvester, but it is of single row only. So we are in search of the manufacturer who will help for fabricating 3 rows or 2 row, multiple row harvester.
We can connect. No, or I think we have not tested.
Have you got prototype of?
Yes, sir. We are having prototype.
But what is the difficulty you had till now?
So cutting and conveying efficiency is good, but only the problem is it is as it is of single row, so efficiency is less.
No.
Field
Did you
efficiency.
talk to any industry till now or never?
Yes, sir. We are not able to find out the manufacturer for multiplying it.
No, any manufacturer you met.
Yes, sir. Yes, sir. But
What they told. We want to know the feedback.
sir, they are facing some difficulty in fabrication for that.
Okay. There is some problem in somebody can find out. Did you actually what industry wants is if you can find out what difficulty they had, if you list them, because if they already manufacturing, they have some difficulty. Maybe some other colleagues can help you to solve the difficulty. First question.
Somebody is there. He's saying that I can help.
Yeah.
Okay, they will, but they, without knowing, they will help. But I think when they know difficulties,
I think remember what we have been discussing for 2 days, that if you make the industry partner from the very beginning, see what industry does it has a much better assessment of market. Because they will work on whatever themselves. Okay. So a scientist does not have that one unless you do a proper survey yourself. Okay. And if the industry understands that, it will also give you a very good idea of what it will cost. So they will use the standard components, standard parts available. Your design, I can tell you most of the agricultural engineering department, the engineering colleges as such, fabricate based on what is available there. Okay. 7 इंच के बजाय 9 इंच की पुली बनाए तो 9 ही लगा है ना, और वो नहीं मिली बेल्ट फट मिली तो पुली बदल दे है ना. So we try to, because we are working on developing a principle. Okay, we are not really developing a manufacturing design. Okay, we are not developing prototype for manufacturing. We in academics we basically work on testing a principle, something like that mechanism will work, it will work. Then it has to be translated into manufacturing. So that, but if you have a manufacturer from the very beginning,
they will tell you, this is not going to go any further. Why you waste time? Okay? Or you go this approach. Okay? So I'm very strong about that, but I failed. I tried to do in 95, in ICR 96. Now our new DG is trying to push that we should have a collaboration with industry. Anyway, never late.
I have an idea. AAAE already we have chat.
Yeah.
Interlink forum.
Yes.
We can start a topic like this that people can exchange.
Sir, we have two challenges as far as the machinery is concerned. Sir. One is sorghum
harvester, another is cotton picker. So for both it is for PDGV Akola, Marathwada with both.
Okay, very good. So I think the sorghum and cotton we already had good presentation from the farmer. Okay, and so anything else, madam?
No, sir.
ढूंढेंगे तो मिल
अगर
जाएगा.
कोई हेल्प करने के लिए है तैयार तो we can approach them.
He offered already.
I see my card here.
Okay, sir. Okay, thank
चलिए.
you. Thank you, sir.
We need a forum to.
So we can do.
ज्वार की रोटी खाने को तो मैं भी तैयार.
We are ready to do testing our.
Okay, now anybody else, anything bothering anybody or something come in mind? Okay, okay, if that is done. If that is done, now let us try to close this thing. I will start with, first of all, we recognize the team which started planning the whole thing, okay, working on that. And I have two people to recognize, Dr. Indramani Mishra, the Vice Chancellor, and Syed Ismail. Can you both stand up? And I was the one to poke them, bother them almost every day and checking up what is happening. Okay. So I'm very proud. Both of them are my students. Okay. I still consider myself as a teacher. Okay. So I have the privilege of asking them in odd hours to do the jobs. So I'm very proud of them and I think they did a wonderful job. Okay. Both of them have excellent teams. Syed has his own team, managing systems, and Professor Indramani has his team from Parbhani for various tasks, okay, on that basis. So I leave up to them to identify the team and recognize, okay. You say that.
Okay. Team Parbhani, who were engaged with this, please come forward. Ratawadi, Kailash, please come forward. All those who from Badlapur or from Aurangabad are from campus. Many have left, I think, but this is the core team. Please come. Dr. Beg is sir cotton specialist. Very recently, we released BT state cotton varieties, 3 of them from here. And Dr. Mai Pawar, he is credited with bringing 2 biofortified palm millet varieties. 4 total palm millet varieties in the country biofortified. 2 are from Parbhani, and he is the leader. High ferrous content. And Dr. Ahire is Dean, College of this ADP Badnapur, and very hard worker. And he connect, the best thing about him is that he find employment for his students in different organizations. So wonderful work. Basically, someone was looking for suitable accommodation. We have here transporters conference, and all the hotels were booked, completely sold out. So they found out, some 7 April and some others. Dr. Kailash is, as you saw, metallurgist, but all the groundwork he was doing, and since yesterday he is helping in the presentation also, and lead work Dr. Koke, Dr. Avari, and my friend Jale and They all were managing here, so KVK in charge and Dr. Katie, where is Katie?
He has a monitoring team today. He went.
So there are a lot of different teams come visiting, so they have gone there. But wonderful work, congratulations. Thank you. Without you, it is not possible. And then separate.
That's on the MGM team.
Please, MGM team.
Dr. Chauhan.
I would like to please come.
MGM team, no. No, he's not MGM team.
Actually, we are really thankful to MGM and particularly their boss, Karamji, who wanted to come here join, but he came from his village. He is very senior person, so not feeling well. Otherwise, he was very much desirous to meet sir and all of you. And but Dr. Suryavanshi, he came yesterday, and Vice Chadha, and they are all, you know that this was a different kind of meeting. One side plant doctors and engineering doctors, the other side medical doctors. So wonderful, and they really, after that I had 2-3 rounds of meeting, and they were appreciating the program very much. So thanks for all your effort. Not only that, facility and other things, they are 100% dedication. Both of these, two principals, they use their own car, whatever. And not last 1 month, we have been working 3-4 physical meetings I had here with them, and kudos to you and your whole management. Thank you. We will keep on this. Thank you very much to all of you. Thank you.
Now, the next year, you should get your teams. Okay. Are they all gone? Yeah. And you had a strong support from TNU. Yeah.
He is a real man behind starting in AAAE there, running to all the government offices. He's my friend, so he's a very good registration, GST, starting everything. And plus here all the printing work, everything, all of them he only, including this, making everything coordinated on the whole program. Venkat Raman, my junior, he's sitting in Kumbhakoണം. AAAE logo was not correct. We had a old logo, small resolution. Starting from logo making 1 year back. He's involved in all the artwork, the banners. You see all the work that without him is not possible. And Amit Cholwan is an engineer. He's working with me. He is the man behind the whole thing operating here and the whole rest of work. He's retired, but he is a technical person. He's also working all the work. We all learn that. Really thank you all. Without this particular symposium would not have been possible. Thank you.
Also recognize support from your
yes. Yeah, a lot of Vishwanathan and Venkaswamy and Kumar. I think we discussed it when I was in Coimbatore last time. We had AAAE and we conducted a training program for students, okay, for TNA students. That time they were all there. So we discussed that time we are going to have this particular one. So you all come and support us. And I think basically I was surprised actually. We had 47 paper presentation. And you won't believe, people asked me, so many still waiting, but I could not take it because it is too much, 20 minutes. Some people ask me, how can you finish in 20 minutes? I told 10 minutes more than enough. And I'm surprised that all the people here, different subjects. People came to me after the presentation yesterday also. Sir, I have not seen like this. The topics are wonderful. We made a change. AAA has made a change to make industry and others give an opportunity. That is our objective. Now we are taking next level. I think I want again tell you, we are taking in next May to Bangkok, and we are going with Agritechnica. Already you've seen website. I would request you only be in touch with our website. Easy to remember, AAAEsociety.org. Very easy to remember. And we are having already full-fledged, it's multilingual. You can see different languages we can enable. And plus it's so much very rich one. So we can have a lot of stuff there among contributors. For example, Madam started a particular question. So we'll have a team, we look for partners, industry partners. So she can post it. And you can be we will implement soon different type of people. Anybody can see our website and be a part of it. Members will have certain privileges like that. So I will suggest you with this thing, and please use the website AAASociety.org. Every information will be updated and given to you. Thank you.
So, tea break will be after this. This conference, this symposium was really unique. First, that from that traditional symposium, co-chair, report, this all they were in Professor Singh. So, and that's why the reason we could have so many presentations and a very good discussion also. So this is one thing we should learn from this symposium, that a lot of time we waste reading traditional symposium, co-chair, they speak more than the speakers. And same thing, everywhere they speak same sermon. We can get rid of it. This is one learning from this symposium, which we discussed all three under the guidance of Professor Singh. No chair, no co-chair, nothing like one. Some monitor should be there.
Yes.
Monitor, not moderator. So monitor, come moderator, you can say. So this basically enhances the efficiency. And that's why we could do. This is one learning. And there was no, let me tell you, there is no shortcoming in doing this. So this is one. Second, we organized this event after this is very much important that after a long gap we organized one event of AAA. So for us it was very challenging and very much required. And the kind of response we saw from all stakeholders, academia, industry, government, students, all they came. That was one very much satisfying, and it was full theory, not post theory. Because content and program was made like this, people themselves thought, no, we should attend it. And as discussed yesterday, many people came not from government support, not from industry support, they came from their own, expenditure, rather investment. Including my friend, Dr. Engineer Neeraj Srivastava. He was taking rest in Lucknow, but no, AAA is there. I will come and put up my heart. And many of you, all of you who are superannuated, kudos to you. So that's the grand whole of the team. I am not taking name. Everybody deserves applause. Third, very good discussion. And we will make out with the help of team with further recommendation. So definitely certain recommendation like which we pressed. This is what the last portion was the beautiful portion. That when Madam Gupta, what's your name, Madam? Deshmukh. She was looking for some industry and he said, so he was saying what they say, कोई होता है ना अच्छा गाना गाया कोई प्रोड्यूसर था ओके उसको तुरंत ऑफर दिया. So something like that. You see ना ढेर सारे प्रोग्राम में देखते हैं कि किसी ने अच्छा गाना गाया जो लॉन्च करने वाला कौन है वो साथ में बगल में ही बैठे हैं लंच करने वाले एटलीस्ट ही गेव ऑफर ये पर्पस था इसका लास्ट में sometimes certain things happens naturally but they are very important so that was the purpose to connect. The most important thing is yesterday's presentation you might have seen everybody is saying don't work in silo. The message, international message was saying don't work in silo. Here also we want to say that don't work in silo. And then this kind of symposium are very important. We had representation from 3 universities. Konkan we could not get because maybe little far off, but all 3.
Some reason.
There was some reason, but we got good support from 4 universities of Maharashtra and a lot of national representation is there. National representation from all corners, moving corners of the country. We have and this international representation also. So thank you very much. We will make points, recommendations, certain things which we discussed on subsidy and other issues which are basically very much which we can say being international organization and having experience of life in this area. So we'll come out with some recommendations which we will put up on the website. We will take your comment and then we'll finalize and definitely we will share with the government also and with the universities also about how much more of research should be there and how this should go. Thank you very much. And the most important students, they were so happy, sir, that there are 30 other students from MGM and from Badnapur and from Parbhani. They got opportunity and this is the one of the most important benefit of this symposium. So very good, carry it on and whenever you get opportunity, take it with all seriousness. It's not like just come and go. So attend and many of you attended, made note, very good and carry it on. Thank you very much.
An apology that I have been rough with few people on a different times, different occasions. So please don't take it, relax, okay, it's over. So we did in the interest of the whole organization. So we stay on time, okay, and to the point. So if anybody felt hurt, I'm really sorry, I apologize for it.
It's only for time management. I remember one anecdote. I traveled to Thrissur and I had to make my presentation of my PhD work. Professor Singh was chairing and he said, you have 3 minutes. So I said, that 3 years I work. But that's what the message that no, when there is time positive, time constant is there, good things can be said in short time. Thank you.
The conclusion.
Thank you very much.
Thank you. Thank you.
I just want to say thanks to AAAE for giving us opportunity, VNMKV, Parbhani and MGM to host this symposium here at MGM Aurangabad. Thanks to all office bearers of AAAE. Thank you very much.
Hi, Hannah.